Orbitals.
These are orbits. Okay, they're on this specific path. The region of space, where are those? Those are your orbitals because they have this region of space that they could be in for your orbitals or for your region of space. So this really would only represent that first energy level. But you have the key idea with this is that it is a region of space. So this would be the first level, the first energy level, which only has your s orbital. But with that, we now have another region of space that overlaps that. So my second energy level, my second s orbital. So it's that entire region of space for your s orbital. And then so you have the sphere in your first level, the sphere in the second level, then your sphere on the third level. They overlap each other, and that was the purpose of that YouTube video, showing you how they overlap each other. So it's that smaller and smaller space. So as your energy level increases, what happens to your distance from your nucleus? It's what? Nope, it is what? Increase. Okay, so as you have more and more energy levels, you're getting further and further away from the nucleus. You're getting more electrons. I don't remember what the other ones are. But that's your, and that was the purpose of showing this, was that they're overlapping each other and getting those energy levels on those different levels. Does that make sense? So the key idea for that is, so this would be like energy level, whatever number this was, 5 or 6. And then you have one so they can go out as far as this, but they're not going to go any further than that. And then the other one is limited to just that region of space, that region of space, that region of space. So your orbitals are a region of space. Number 2, what is the electron configuration of an atom, Brian?
It is the orbit, right?
Need a little bit more information. Okay, we'll get back to you. Why is it important in chemistry? Why do we need to know about electron configuration? Okay, this is another key idea that we need to get. Do you have it? What's the definition, Brian?
It's the complete arrangement of electrons in an atom.
Okay, why is that arrangement important? Okay, page 108. Key idea. Why is electron configuration so important? Do you remember, Jackson?
Well, it says it's important because it tells how the atom is chemically bonded to other atoms, and it influences the shape and properties of the molecules that are formed.
Okay, so it is determines your atom's chemical and physical behavior. So what is it going to react with? What does it look like? Number 13, what is a quantum number, Sam? Okay, big idea. We have 4 quantum numbers. What do the quantum numbers tell us, John?
Is it the address of the electron?
Okay, so we have 4 quantum numbers. What's the first one, Sam?
That's like N.
Yes. What's it called? Do you remember?
No, but I'll look. Is it principal quantum number?
The principal quantum number tells us what? Do you remember?
The electron shell.
Okay, the energy level, the shell. What does the second one tell us, Travis?
The second one tells us its shape or type of subshell.
Okay, so so the letters in order. So the first one is,
N or S.
okay, so S is what shape, class?
Spherical.
What's the next letter?
P.
P, which is what shape?
Dumbbell.
Dumbbell. What's the next letter?
D.
Which is what shape?
Cloverleaf.
It's really the clover leaf plus that other one on top of each other. What's just the next one after that? F and then
G.
G. Okay, so the energy level tells you how many orbitals you can have. So if I have S, P, D, F, and G, what energy level do I have to be on?
5th.
The 5th energy level has all 5 of those orbitals within it. Okay, so we did the first, the second. What's the third one? Do you remember, Ben?
The third one was the electromagnetic, or the magnetic, like the M sub L, or...
Okay, it is M sub L. It is called the magnetic quantum number. What does it tell us?
How it's spinning. Or
Not how it spins. That's your spin quantum number.
Oh, the X, Y, and Z.
Okay, it tells us our orientation in space. So is it left or right, up or down, inside and out? That's what that's what quantum number?
Magnetic.
Magnetic quantum number. And then the last one tells us
The spin.
the spin. So clockwise or counterclockwise, or the last one. What is the Pauli exclusion principle, Jackson?
that says that no two electrons in an atom may have the same set of 4 quantum numbers.
Good. Why does this principle limit the number of electrons that can occupy a particular orbital? Anybody? We kind of mentioned this before. Okay, Hans tells us the order in which they fill. Hans is telling us that they're going to, the p orbitals, they're going to fill one at a time before they pair off. Why does this principle limit the number of electrons that can occupy a particular orbital?
Is it the
Because it says there's no. I don't know. You can only have 2 electrons.
And what?
And
Okay, in an orbital you can only have 2. Travis, do you have a thought?
Okay, it says if 2 electrons occupy the same orbital, they already have identical N, L, and M sub L, so the spins have to be different.
Good. Okay, perfect. Which means in each region of space, you can only have 2 electrons. So your p orbitals, we have 3 p orbitals, which gives us 6 electrons. You're going to have 10 electrons in your d, which means we have 5 orbitals, or 5 regions of space, which you saw those clover leaves in all those different directions. And you can have 7 different orbitals on the F block because you have those 14 electrons. So only 2 electrons can occupy each space. What are valence electrons, Julian?
The outermost electron.
What is the maximum number of valence electrons an atom can have? 8. Which is which orbital letters? Say that again? S and P. Because this gives you 2 electrons, this gives you a total of 6 electrons. So it's the highest energy level, your S and your P orbitals, that are giving you your valence electrons. Okay, let's take a look at your homework. The first page, number 2, what'd you get, Travis?
Number 2. I got Mendeleev's periodic table was accepted by scientists because it is remarkably similar to today's.
Okay, we need a couple of other, okay, we use that for our basis of today's. Why? So you kind of went a little bit circular reasoning with that, Megan?
Because he based it primarily on properties.
Okay, that's part of it, Ben.
Because of the ability to predict and
Key idea.
to predict the results of future investigations, and it was orderly arranged.
Okay, so the undiscovered element, key idea for that. And it was also a very concise, orderly fashion. What is the modern periodic law? What did you put for that, Sam?
Was that part of number 2?
That's number 3.
Oh. Physical and chemical properties of element and periodic function.
Okay, their periodic function of what? Is it arranged on a periodic table?
I don't know.
What is it, Megan?
Atomic number. Mass.
Increasing number of protons. No, you're right. Increasing atomic number, increasing number of protons is how we're getting that order on our periodic table. What do we call a row going across the periodic table, class? A period. Okay, we're on page 116 in your books. And then before we get into that, we're going to introduce you to magnesium. Your fireworks. Have you seen those flashers for your fireworks?
Yes.
The ones where they just and they flash on there. That's not pure magnesium, but it has magnesium in it. And that's if we were to burn pure magnesium, it's very, very bright. So magnesium. I'm a happy mix in any social gathering of elements, making friends with anyone, even moody hydrogen. I'm a sparky, and I'm always cause a reaction. I'm a smart aleck too. I can speed up your body processes and make you rush to the bathroom. The laxatives, Epsom salts, and milk of magnesia are both made using my salts, which also give a bitter taste to food and can leave a bad taste in your mouth. I am a silver white metal and burn with incredible intensity in a bright white light. My splendoriferous powers of combustions are used in flash bulbs, distress flares, fireworks, and incendiary bombs. Strong and light, I can help make bike frames, car parts, and aircraft engines. Have you seen the old photography setups? That poof that they'd have?
Oh, yeah.
That was, they would use just a tiny bit of magnesium to create that poof with it. And magnesium is also a very soft metal, just like sodium. You can cut it with a butter knife. It is highly reactive in that pure form for that one. What do you Matthew?
Gotta go to the restroom.
Okay. So we're on page 116, and we're talking about your general classification of elements, and one of them is based on whether they're metal, a non-metal, or a metalloid, or a semi-metal. It's the same idea. What is a characteristic of a metal? So when you hear the word metal, how would you describe metal? What's one characteristic? Which one, Brian?
Solid.
Solid. Okay, what's another one? Travis?
Cold.
Okay.
Or hot.
Okay, so one kind of temperature extreme. What's another one, John?
Hard.
What's another one, Sam? Shiny. Lustrous. Luster. Do you remember that term? How else would you describe a metal? Yes?
It conducts electricity.
Good. And also, what happens when the electricity goes through it?
You touch it, you get fried.
It's hot.
It gets really hot. So it's also a thermal conductor. A lot of heat can go through it. A non-metal would be a gas or very brittle solid, so ceramic type of material. They're not very good conductors. They're non-conductors, so they're insulators, and their surfaces tend to be very dull when they're non-metal. A semi-metal. What do you think is going to be true about a semi-metal?
It
Any
has
ideas?
different qualities from both.
What's one, Ben?
Well, it might be sort of like a metal. It has some of those properties, like might have hardness and shine.
Okay, so kind of that in-between-ish. John?
Well, I'm sure it could probably conduct, just not well.
So it'd be semiconductor, yes?
Probably more easily broken or bent than normal metal.
Brittle?
Yeah,
Okay.
more brittle.
So good ideas for that. And those are one way that we can classify our periodic table. So page 116. Another way that we can classify them is by your main group elements. So that's what we talked about right before earlier today. And your main group elements are your representative elements, which is your group 1. What's your group 1 called? Do you remember? Group 1A on your periodic table. Right here. What is this called?
Maybe.
Alkali.
Okay, we need to be specific. Do you remember what is it called?
Alkali metal.
Alkali metals. Alkali metals have some specific characteristics in general. Sodium and potassium, they're found naturally or typically with what charge? So what ion? So group 1 has what charge?
Positive.
Positive 1. Okay, so we're on page 116, page 117 in your book. They're never really found as free elements, but we always see them with that +1 charge. The second group, do you remember what this group is called?
Alkali earth metals?
Alkaline earth metals. What charge do they tend to have?
2 positive.
2 positive. And those also, they tend to be ions. We don't really find them in the earth. Group 16, which is your oxygen family. Do you know another name for that one? Do you remember that? Halogens is group 17. It's like chalcogens. So your oxygen family is also called your chalcogens, if you remember that from 9th grade. And then right after that, or your chalcogens also, they tend to have what charge?
4 positive. Something.
-2 charge. Then fluorine, chlorine, bromine, iodine, astatine, all these, those are called your halogens. They tend to exist as a gas, and they tend to have what charge? -1 charge. And the very last group is called your noble gases. Also, okay, one other idea with group 17, halogens literally means, do you see that in your book? In italic, what does halogens literally mean?
Nope, I don't see it.
Page 117. What is it? Salt former. So, for instance, table salt. What's the chemical formula for table salt? Sodium chloride. In chemistry, the scientific definition of a salt is not just salt that you can eat. Okay, so that is a salt with your sodium chloride. But you also have like potassium chloride, which do not eat it because it was nice knowing you. So it's a metal and a non-metal, but that's anything with your halogen, they're going to be your salt formers. So it doesn't have to be just the salt that we eat. There's other types of salts. But halogens will react with a metal to form your salts. So that's why they're called that. And then your very last group is called what? The last 18?
Noble gases.
Your noble gases. They have how many valence electrons? 8. They have a full outer shell. That is why they are inert. Remember what that means, inert?
Don't move.
They don't like.
They're
Not
not real.
that they don't move, but
They don't like reaction.
they don't react with anything. So that's what inerts. They do not readily combine. Very few of them do combine with that. Okay. Take a look at example 8.1. It says classify each of the following elements as a metal, non-metal, or semi-metal. Okay, so that's one way to classify. Is it a metal, a non-metal or semi-metal, so that's one classification, and as a main group element. So is it a transition metal, an intertransition metal, or if it's one of our main groups, which would be your alkali, alkaline earth, calcogens, halogens, noble gases. Okay, so the first one is chlorine. Okay, so first of all, is chlorine a metal, a non-metal, or what's the other one, semi-metal?
Non-metal.
So take a look at your page 115. Chlorine is a non-metal. Now, chlorine, based on where it's looking on your periodic table, is it a main group element? Based on where it's on your periodic table, what's the name of the group that it's in?
Halogens.
It's a halogen. So two answers for chlorine is a non-metal, and it is a halogen. Okay, letter B, uranium. Find uranium on your periodic table. Do you see it?
Nope.
Where is it? What's the atomic number, Brian?
It's in the bottom area.
Okay, so it's in
an
that bottom?
transition.
Okay, so good. This is an intertransition metal, so it is your unstable bench on your periodic table. So the uranium would be an intertransition metal. Okay, the other question, is it a metal, a non-metal, or a semi-metal?
Semi-metal.
Okay, what color is it?
It was metal.
It's
So
like
page 115,
silver.
that's the color. Okay, page 115 is where we're finding that out. So based on where it is in the periodic table, what color is it? It's blue, therefore it is a
Metal.
metal. Okay, so that's page 115. Okay, what about letter C, argon? Find argon. Argon is a non-metal. Argon has a group name. What's the group name?
Noble gas.
Noble gases. Okay. Iron. Find iron. It's a transition metal. Everybody found it?
No.
Okay.
Number 26.
26 is the atomic number.
Found it.
Okay, so is it a metal, a non-metal, or a semi-metal?
Metal.
Metal. Calcium. Find calcium.
Metal.
Number
What
20.
group is calcium in?
Alkaline.
The second group, so alkaline earth metals. And then what type is it? Metal, non-metal,
Metal.
or semi-metal. Okay.
It's blue.
And the last one, you probably don't know where this is. Tellurium.
Found it.
What number is it?
No clue.
No clue.
Okay.
Thallium? No, that's not it.
In the back of your book, it has an alphabetical index.
So wait, what did you say?
Tellur. So in the back of your book, you have the alphabetical index. What number is it? Number 52. Find number 52.